Hello everyone, I am Surendra, Master Teacher of Mathematics in Vedantu. In continuation to my sessions on CMI and ISI preparation, in fact these sessions are helpful for JEE Advanced also. Today I am going to solve the paper of CMI 2019 Part B. In my last session it was Part A. I gave you the analysis also that how difficult it was and from which topic how many questions were given. Today also I will be doing the same thing in the end. And also do not miss that teaser question which I will be sharing in the end of this session. So let us start solving these questions. So we have given that for a natural number n, denote by map n the set of all functions f such that 1, 2 up to n2, 1, 2, and so on up to n. So you can see the domain of this function is same set as that the codomain. Okay, although range we cannot say, but yes, range will also be the subset of this set only. Now for f comma g belongs to map n, fog denote the function in map n that sends x to f of gx. A part says let f belongs to map n if for all x that belongs to 1, 2, 3 up to n, fx is not equal to x, then we have to prove that f of is not equal to f. Now let us do this A part first. So we are given that fx is not equal to x for all x belongs to 1, 2 and so on up to n. Okay, now they are asking us to prove that f of fx will not be equal to f of x. Now it looks like that we have just replaced x by fx, and this relation here that we have to prove is just the rearrangement of this given relation only. Now to show it in better method or in better way, I will say I will take x is equal to x1. Take x is equal to x1 and then fx1 will be lying in that codomain only, some of the element from this 1, 2 and so on up to n. Fx1 will be from this set only. Now consider this value f of x1 as one of the element in the domain. Okay, because we are given that for any x that belongs to 1, 2 up to n, f of x cannot be equal to x. So I think we can very easily say that f of fx1 cannot be equal to f of x1. I hope this is clear and this is just easy to say this thing what they are asking us to prove. See, they are saying that for all x belongs to 1, 2 up to n, f of x cannot be equal to x. Now if I take any x as x1 or maybe x2 or something like that, this fx1 that will be the value of this function and it has to lie in the codomain, and codomain and domain they both are same. So this fx1 has to be lying in this set only. So using this relation that given in the question, I can say that for any fx1 that is lying in this set, f of fx1 cannot be equal to f of x1. So I think we are done. Hence we can say that for any x that belongs to, because as we have proved for x1, and x1 is any arbitrary number in this 1, 2, 3 and so on up to n set. So for any x that is from 1, 2 and so on up to n, we can directly say that f of fx cannot be equal to fx. So this first part is done. I will say hence proved now. Now coming to the B part. B part says that count the number of functions f belongs to map n such that f of fx is equal to fx. Okay. Now to prove this thing, let us first understand that we want f of fx to be equal to fx. That means for any fx1 that belongs to 1, 2, and so on n. Okay, in fact this will be one of the element of the range, one of the element of the range of fx. Okay, so for any such element, please understand, you can take fx1, take this fx1 to be equal to, let us say, n1. You can see, if we want this thing, okay, then because this, for this relation to be valid, we will require that f of n1 to be equal to n1. So what I have tried to say here is actually that whatever element we are having in the range, okay, and because domain and codomain are same set, this element in the range will be there in the domain also. So for all such elements, that are in the range, if you take the value of that function, considering that value in the domain, it has to give you the same element as the value. Okay, so if n1 is in the range, the value at n1 for this function has to be same as that n1. I hope that is clear. Now, you cannot have situation like part A where no x having value same as fx is equal to fx not equal to x, because otherwise we cannot have FOF equal to x as we proved in the A part. So there has to be, so also let me say, using A part, I can say there is at least one such n1, there is at least one such n1 for which f of n1 will be equal to n1. I hope this is clear, because otherwise if you are saying there is no such n1, then I think we are in the situation of part A. So then FOF cannot be equal to f, that we have already proved. So there has to be at least one. Now I will do this question in some parts. Let us see how. Okay, so suppose my range is having only one element. Suppose range has only one element, and this can be chosen in n ways, and it has one element, say n1 maybe, okay, and this can be selected in n ways. Now what will happen, let me show you. So this is 1, this is 2, and so on. There is n1 here and then n here. Now here 1, 2, and so on, n1, and this n here. Now this n1 has to be connected to this n1 only. Okay, and because this range is having only one element n1, so I have to connect all the elements 1, 2, and so on to this n1 only. So number of ways for this case would be, I think, NC1. NC1 is for which element you are going to keep in your range, and then all the other elements, which are, I think, n-1, they will be connected to this element only. So for every element you are having one choice, and this will be raised by n-1 here. Now if range has two elements, say n1 and n2, then I think if I make the same diagram, 1, 2, and so on, n1, and so on, n2, and so on, n, and here again 1, 2, and so on, n1, and so on, n2, and so on, n. So this n1 will be connected to n1, and this n2 will be connected to n2 with the same reasoning I gave you earlier. Now all the elements 1, 2, 3, and so on, other than n1 and n2, they has to be connected with either n1 or n2. Okay, you can connect to any one of them. You can check whether, let me check if my f1 in this scenario, let me check if my f1, if it is equal to n1, will this FOF is equal to f condition will be satisfied or not. Let me check. So here I will be putting x is equal to 1, then FOF1 you can check will be FO n1, because f1 is n1, and f of n1 is actually f1 because we have taken f1 is equal to n1. Okay, f1 is equal to n1 and f of n1 is actually n1. Okay, and hence this is equal to f1. So you can see if I choose f1 is equal to n1, or I could have chosen f1 is equal to n2 also. In both cases this will be satisfied. So what I am trying to say here, that number of ways for this scenario, number of ways for this would be NC2. NC2 is for which two element you are going to choose for to keep them into the range, and then we are having two choices for all the remaining elements. Two choices for all the remaining elements which are n minus 2. So this will be the number of ways if I keep two elements, exactly two elements in the range. Now same way if I keep doing okay, so similarly if three elements in range, then number of ways would be NC3 and 3 power n minus 3, because every remaining element will have three choices. So total number of functions would be summation NCI and I raised to the power n minus I. Okay, where I will start from 1 and it will go till n. So that is the answer for this particular question. It was little difficult question to think in that exam pressure, but otherwise question was decent, but still I will call this question as a difficult, especially B part. A part was easy, but not B part. Now coming to question number 2a, count the number of roots w of the equation over complex number that satisfies this mod w plus 1 greater than or equal to root 2 plus root 2. Now to do this question, first of all, we should understand this root 2 plus this root 2. Can I write this as 2 cos pi by 4 here? This thing is actually root 2, you can check. If I use this way, it will become 4 cos square pi by 8. And this will give you 2 cos pi by 8. Okay, so now there are two things, please understand. I need to find the common values which satisfies this equation. Let me call this as equation number 1, and z plus 1 greater than or equal to 2 cos pi by 8. This is again one very easily found locus. It is actually outside region of a circle whose center is at minus 1 comma 0 and whose radius is 2 cos pi by 8. Okay, so if I draw both the equation on this Argand plane, this one is very easy. It actually represents the 2019th root of unity. Okay, so I can draw a circle whose center will be at origin and radius will be 1. Whereas the second locus represent the circle whose center is at minus 1 comma 0. Here this equation 1 is represented by a circle whose center is at 0 comma 0 and radius is 1. And also the first root will be at 1 comma 0 and other roots would be lying on this circle, and that will divide the entire circumference in 2019 equal parts. One very standard theory of nth root of unity. So here taking minus 1 comma 0 as center and 2 cos pi by 8, which will definitely be greater than 1 but less than 2, there will be a circle like this. Okay, so here we are looking for that those z which lies outside this circle and also lying on the circumference such that they satisfy equation number 1. So I think we are looking only in this region how many 2019th root of unity will be lying. Now to solve this, let us do some calculation. If I join this point to this and this point to this, you can see this is 1, and this is 2 cos pi by 8, or let me put this way, this is isosceles triangle. So if I join this center 0, 0 with the midpoint of this, let me call this as A, this as B, and let me call this as M. If this angle is, let us say, alpha, okay, or let me put this way, this AB length is 2 cos pi by 8, so this will be cos pi by 8 here, and this will also be cos pi by 8 here. Okay, so I think we can easily find alpha here. Actually, in this diagram, you can check this sine alpha will be cos pi by 8. You can check. Sine alpha will be cos pi by 8 upon 1. Okay, that means this alpha, which has to be acute, it will be pi by 2 minus pi by 8, I think 3 pi by 8. Okay, and this angle will also be alpha. So if I find this theta, so theta will be 180 pi minus 2 alpha. I can write this as pi minus 3 pi by 4, which will give you pi by 4. Okay, so basically these 2 points, let me call this point as B and this point as C. My potential values of W, which I am looking for, they should be lying within this angle range, which is between minus pi by 4 here to pi by 4 here, because if this is theta, this will also be theta. By symmetry we can say. Okay, so how many roots will be lying within B to C, that we have to find. Okay, so to do this thing, let me make another diagram. So as I told you in this slide, I am looking for those W lying between B to C, where B and C both are at angle pi by 4 from positive x-axis. So here pi by 4 here, pi by 4 here. So this is my B here, this is my C here. So, and 1 automatically it is there, 1, 0 will be there, and it is satisfying this also. So how many values will be lying in this? To do this thing, I think we understand that any ith root here, suppose this is my ith root, then this angle is actually 2 pi upon 2019 into I. Okay, this ith root will be above 1, 0. So how many roots are above 1, 0? I think I can directly say same number of roots will be lying 1, 0 also. Okay, so here I am looking for this 2 pi by 2019 I should be less than or equal to pi by 4, because their equality sign is also there. So we can even go up to this point B, because this angle is pi by 4 here. So less than or equal to pi by 4. So this I will be less than or equal to, I think this will be 2019 upon 8. Yeah, upon 8. So this I comes out to be, if I divide this by 8, it will be 8 to the 16, 4, 8 5 is a 40, 1. So this will be 8 to the 16, 3. That will be after decimal. So I will be less than or equal to 252. So that means if I put I is equal to 1, 2 and so up to 252, these many roots will be lying above this 1, 0, and same number of roots will be lying below this 1, 0 also. So number of roots W will be 252 into 2 plus 1, which comes out to be, let me put it 5 here, and 4, I think 505, not 405, 505. Yeah, so that is the answer of this question. Little bit tricky, but if you understand it well, I think this question is easy. Okay, now coming to next question, that is B part. Find all real numbers x that satisfy following equation: 8 power x plus 27 power x upon 12 power x plus 18 power x is equal to 7 upon 6. So to do this question, let us first observe actually that 8 and 27 and 12 and 18, they are such, their products are same. 8 into 27 is same as 12 into 18. In fact, I can write 8 as 2 power 3 I can write 27 as 3 power 3, whereas 12 is 2 power 2 into 3 power 1, and 18 is 2 power 1 into 3 power 2. So you can see these numbers are written in combination of 2 power and 3 power. Also, some of you may be looking at the answer directly by saying that if I put x is equal to 1, so 8 plus 27 is 35 and 12 plus 18 is 30, so it gives me the answer, isn't it? In fact, someone can say that if we divide numerator and denominator by 8 into 27 power x, okay, so this also becomes, you can check, 27 power minus x plus 8 power minus x upon 18 power minus x plus 12 power minus x is equal to 7 by x. I hope you are looking at what I am doing. What I have done, divide by 8 power x into 27 power x, because 8 power x into 27 power x will be same as 12 power x into 18 power x, so we will get same thing. So what you can see, by doing this thing, we have got left hand side same as here in the left hand side. The only difference is that x has been replaced by minus x. So in this way we can say this function is actually even function. So whatever value of x we are going to get, I think negative of that x will also be one of the solution. Now to do this question, how we are going to do? Already we have found by observation that x is equal to 1 is going to be the solution. Now to do this question, what we can do, we can take 2 power x as some u and 3 power x as some v. Then this given equation will become u cube plus v cube upon, in the denominator I can write, or it will be u square into v plus u into v square is equal to 7 by 6. Okay, now u plus v is coming common in numerator as well as in the denominator. Then it will be u square plus v square minus uv, and here it will be just u into v. U plus v will be cancelled. U plus v cannot be 0, so we can cancel it and we will get this to be equal to 7 by 6. Now doing cross multiplication, 6 into u square plus 6 into v square minus 6 into uv is equal to 7 into uv. Okay, this will give you a quadratic in uv. So 6u square minus 13uv plus 6v square is equal to 0. So if you solve it, you get this to be 2u minus 3v, one factor, and 3u minus 2v as another factor. You can check. Yeah, it is, I think, correct. So either 2u will be equal to 3v and u is 2 power x, so we will get 2 into 2 power x is equal to 3 into 3 power x. 3 into 3 power x. Okay, and here I think only possible answer will be x is equal to minus 1. You can put it this way also, 2 upon 3 raised to the power x plus 1 is equal to 1. Then this x plus 1 has to be 0 and hence x is equal to minus 1. Or the second scenario, 3u is equal to 2v. So here it will be 3 into u power x is equal to 2 into 3 power x. So here you can check x will be 1. So we are getting two answers for this question, 1 or minus 1. So number, find all real numbers x. So answer should be written this way, x belongs to 1 comma minus 1. You should take care whether they are asking number of solutions or whether they are asking the solution. So answer here is 1 comma minus 1. Okay, so I think if you understand that after doing this kind of substitution we will get easy calculation, then it is easier question. Otherwise I will rate this as medium to slightly difficult, you can say. Okay, coming to question number 3, we have to find this definite integration from 0 to infinity 1 plus x square raised to the power minus m plus 1 dx, where m is a natural number. Now to do this question, I think we can put x is equal to tan theta, one very standard substitution in such type of questions. Then this integration I will become, this lower limit will be 0 and upper limit will be pi by 2. When x is 0, theta will be 0. When x approaching to infinity, theta approaching to pi by 2. and this will be secant square theta raised to the power minus of m plus 1, and dx will be secant square theta d theta. So you can see the secant square theta power, this 1 will be cancelled with the secant square theta. I can write this as 0 to pi by 2 secant square theta raised to the power minus m. We can also write this as 0 to pi by 2 and d theta also here, cos raised to the power 2m theta d theta. Now this one is direct if we use Wally's formula. We know the result, we can do it directly, but if this question is of 10 marks, we are not supposed to do that way. Rather, I will be taking this as I2m, and then I will use that method to prove that Wally's formula. So here, to solve this I2m, we can write this as 0 to pi by 2 cos raised to the power 2m minus 1 theta into cos theta d theta. And then we will take this as the second function, this as the first function. So this will become, first will be cos raised to the power 2m minus 1 theta into sine theta, and this limit will go from 0 to pi by 2. Both limits are such that pi by 2 will make this cos 0 and 0 will make this sine 0. So this entire thing is going to be 0 only. Then minus 0 to pi by 2. Differentiation of first function, that is 2m minus 1 into cos raised to the power 2m minus 2 theta, then minus sine theta. Up to this point we have done the differentiation, and then integration of the second function, that is plus sine theta d theta. So this I2m will actually be equal to 2m minus 1 common. This minus will become plus, and we will get 0 to pi by 2, and here it will be cos raised to the power 2m minus 2 theta into 1 minus cos square theta. I can write this d theta. Okay, so this I2m, let me write it here, I2m is actually equal to 2m minus 1 into this cos 2m minus 2 theta into 1. I can write this as I 2m minus 2 minus, when this is multiplied, this cos square theta is multiplied, this will be I2m here. So let us bring this I2m on one side. So we will be getting 2m into I2m is equal to 2m minus 1 into I2m minus 2. So what we have obtained here is I2m is equal to 2m minus 1 upon 2m into I of 2m minus 2. It is not minus 1, it is, I think, minus 2. So here you can check in the suffix here, this number keep on remain as even number only. So if I do it again, this will be 2m minus 1 upon 2m. Okay, so what you can see, this 2m was here, so we got 2m in the denominator. So if 2m minus 2 is here, we will be getting 2m minus 2 here. And this number here, 2m minus 1, was 1 less than 2m. So I can write this as 2m minus 3 here. And here it will be 2 less, so 2m minus 4. So this way we keep on doing. Okay, so what we will be getting if I keep doing this till end, so 2m minus 1 upon 2m, 2m minus 3 upon 2m minus 2, and so on. I think if I put I0 here, or maybe you can put I2 also, I0 if I put it here, we will be getting 1 by 2 here. You can check how we have got it. I2 would have been, if this will be I2, then it will be 1 by 2 into I0. So this 1 by 2 into I0 has been found using I2 one step just before it. Or if you want to write one more term before it, it will be 3 by 4 here. And I0 is nothing but when power will be 0 here. When power will be 0, that means cos power 0 is 1. So 0 to pi by 2. So 1 into d theta, this will be pi by 2. So here the answer would be 2m minus 1, 2m minus 3. All the odd numbers are in the numerator and all the even numbers are in the denominator, 2m, 2m minus 2, and so on, 4 into 2, and there will be multiplication of pi by 2 also. So that is the answer. You may leave it here, or you can do one thing by multiplying 2m, 2m minus 2, and so on, whatever they are in the denominator. In the numerator also, I think we will get 2m factorial in the numerator. But then there will be square of whatever is here in the denominator. Okay, and this thing in the denominator can be written as taking 2 power m common, it will become m factorial and then square, because I have multiplied and divided by this thing to make this numerator to be 2m factorial. It can be checked. It will become 2m factorial. For that I have to do the squaring of this thing, and if I take 2 common from all the terms which are m in numbers, so 2 power m outside, and it will be m factorial and whole square here into pi by 2. So that will be the answer of this question in other form if you want to write. Now coming to question number 4, which says ABCD is a parallelogram. O is a point in its interior such that angle AOB plus DOC is 180 degree. Show that angle ODC is equal to OBC. Okay. Now to do this question, let us first draw a parallelogram. Call this as A, B, C, D, and O is a point lying in the interior, something like this, and joining O with D and O with C. We are given sum of angle AOB and DOC is 180. So if this is theta, this one would be 180 minus theta. Okay. Now to do this question, okay, and also we are supposed to prove that ODC, this is ODC, let me call this as alpha, is equal to angle OBC. So this is beta. So we have to prove that alpha will be equal to beta. This is what we are supposed to prove. Now to do this question, you can make one simple observation, and this observation may come from this result that sum of these two angles are 180. So maybe some cyclic quadrilateral can be involved to solve this. Now to show you this thing, what I'm going to do, I will make a circle that will pass through O, D and C. From any 3 points which are not collinear, we can always draw a circle. Now if this is a circle passing through ODC, then small construction will help us. If I draw a line parallel to OB from C like this, okay, and then join this D to this point, and let us call this point as E. So this angle has to be 180 minus theta. Okay, because of this OCED being cyclic. Now this angle here, okay, has to be equal to beta only, because this DC, not beta, I think I made mistake. This angle, if I call this as, let us say gamma, so this angle will be gamma here, because DC, AB are parallel sides, and BO and CE are also parallel as per construction. So this gamma, this is also gamma. So if this angle is, let us say delta, this angle will also be delta only. So we can say the triangle AOB is similar to, or rather congruent to, because AB and CD are equal. So AOB is congruent to triangle DEC. Triangle DEC. So we can say that this side AO will be equal to DE, etc., etc. Whatever conclusion we draw from two congruent triangles. Okay. Now we have to prove this alpha is equal to beta, and to do this thing, let us join this O with E. O with E. Okay. Now you can check that OBCE is going to be parallelogram. Why I am saying parallelogram? Please see, this OB is parallel to EC by construction, and OB is equal to EC because of two congruent triangles. So this becomes a parallelogram. Now please see, this angle alpha is actually drawn by this arc OC, you can say, on this D. So can we say this angle OBC will be equal to angle OEC, because D and E are lying on the same side of this arc on the same circle. So ODC is equal to OEC. Okay, so this angle we have proved as alpha, and this will be equal to angle OBC, because this OBC angle and OEC are opposite angles of a parallelogram, which are equal by property of a parallelogram. Okay, so this is equal to alpha, and these two are equal because opposite angles of a parallelogram, and hence we are done. You can see this is a 10 marks question, but it is so easy. But dear all, let me tell you, if you try to do this question by angle chasing without considering this property of cyclic quadrilateral, it will become a huge question, or maybe you will not be able to do this question by giving so much of time. So this question becomes very easy by this method, but not otherwise. Okay. Now coming to question number 5, which says three positive real numbers x, y, z satisfies three equations: x square plus y square is equal to 3 square, y square plus yz plus z square is equal to 4 square, x square plus root 3 xz plus z square is equal to 5 square, and we have to find this sum. Okay, now if we have to do this question by looking at this first equation. In fact, when I did this question for the first time, the first thought that came into my mind was take x as 3 cos alpha and y as 3 sin alpha, which is one very natural thought also, because I have now replaced two unknowns or two variables into one variable only, and then putting x and y in these two equations, we may get equation in alpha alone, and by solving with the help of trigonometric equations, we may get the value of alpha, which eventually will get us the value of this summation which is asked in this question. But this seems very difficult. If you do this calculation, you will find the equation is not that easy to make, and solving is even difficult. Now to do this question, please understand, my first equation is actually reminding me of one right angle triangle whose sides could be x, y, and 3. 3 will be hypotenuse, other two sides will be x and y. And they have given positive real numbers also. So we have every right to take x and y as side length of a triangle. The second equation, if you think of, it can be written as y square plus z square minus 4 square is equal to minus yz, and if I bring yz here, it will be minus 1 here, and if I divide by 2 here, divide by 2 here, it becomes actually cos 120 degree. So you can think of this as a cosine rule in a triangle, such that two sides are y and z, one side is 4, and angle opposite to 4 is 120 degree. Similar to this, third equation can also be thought of x square plus z square minus 5 square upon, I can bring this root 3 xz here, and by dividing xz and then multiplying 2 here and 2 here, it will become cos of 150 degree. So this also gives us idea of another triangle whose one side would be x, one side would be z. This will be 5 here, and this angle will be 150 degree. Now how we can make such three triangles? Okay, here also we are having a right angle triangle whose hypotenuse is 3 and two sides are x and y. So to have such three triangles interconnected, you can see y is common in these two, z is common in these two, and x is common in these two. Okay, and also the right hand sides here are 3 square, 4 square, 5 squares, which reminds us of a Pythagorean triplet. So to make use of this, let us make a right angle first whose sides are 3, 4 and 5. Okay, now to make this kind of triangle whose hypotenuse is 3, other two sides are x and y, I will be making one circle taking this side 3 as a diameter, Okay, so this side is, let us say, AB. Now if you take any point on this circle, join this with A and join this point with B, we will be getting x and y such that x square plus y square will be equal to 3 square. What I'm saying, if you join this A with this point with this point, call this as x, call this as y, we will get x square plus y square is equal to 3 square. But I will do it little later. Please see why. Now, same thing I have to do for the second triangle also, where angle opposite to 4 will be 120. So we can make a circle such that whose chord is BC, and this chord makes an angle 120 degree on any point lying on this smaller arc BC. So any point here, if we take, okay, if this angle is 120, I think this is possible because there will be exactly one such circle for which BC is a chord, and every point lying on this smaller arc subtends 120 degree on BC. In fact, this point of intersection, if I call this point as P, now this is actually that required point which I was looking for. Now if I join this A with P, B with P and P with C, okay, so this will be 90 degree. Let us call this one as X, this one as Y, okay, this one as Z. So you can see this angle is 120 degree, this angle is 90 degree. So my first relation is satisfied, x square plus y square is equal to 3. My second relation is also satisfied because angle opposite to 4 is 120 and two sides are y and z. Now this remaining angle will be 150 degree, you can check. So this third relation is also satisfied by this x and z, and side 5, opposite to side 5 angle is 150 degree, as I was talking in these three triangles. Okay, now what they are asking for, please see, they are actually asking for 2xy. Can you tell me, can you think of this 2xy is actually 4 times the area of triangle APB, because this angle is 90, so half xy will be the area of triangle APB, so 2xy will be 4 times area of triangle APB. Now xz is also area of triangle APC and 4 times of this, because this area of triangle APC would be 1 by 2 into x into z into sine 150. Sine 150 is half, so that will be 1 by 4 into xz. So this xz is 4 times APC, and similar to this root 3 yz you can think of, this is 4 times area of triangle BPC. Okay, because this cos sine 120 is root 3 by 2, so this will be 4 BPC. So this summation, so this required sum is actually equal to 4 times the sum of these 3 triangles, which will actually be equal to area of triangle ABC. And we can write the area of triangle directly as 1 by 2 into 3 into 4, that is 6. 6 into 4 is 24. So answer for this question will be equal to 24. I think tricky question, but if you can think of these cosine rule and Pythagoras theorem, it becomes easy. But I will say in exam environment, exam point of view, not easy at all. Okay. Now coming to next question, that is 6a. We have to find the differentiation of this d upon dx of 0 to ex log t cos power 4t dt. Now to do this question, I think we have a direct Leibniz rule. Okay, this is a 4 marks question, so I think we can use this Leibniz rule of differentiation, which says that differentiation of upper limit, which will be e power x, then we will put t equal to e power x, it will become log e power x here. I think they have not mentioned whether base is e or not, so let us put it this way only, into cos power 4 e power x here. Then minus differentiation of lower limit, that will be 0 because it's a constant value. Then you will be putting t equal to 0, but already because it is 0, there is no need to put anything here. Although you may think of that log 0 is not defined, we take in such case as the limit, but this number is a pure constant. So here this will be absolute 0. So whatever limit you get here, it is going to be 0 only. So this will be the answer of this question, e power x into log of e power x into cos raised to the power 4 e power x. Now, if you do not want to do this way because this is a 4 marks question and you think I should do it in proper manner, then you can do one thing. You can do the proof of Leibniz rule, isn't it? How this can be done, please see. What I will do, I will take this log of t cos 4t dt. We can think of this integration will be some ft, and limit is from 0 to e power x. So we will be putting 0 to e power x here. So this will become f of e power x minus f0. Okay, now differentiation of this thing, d upon dx of 0 to e power x log of t cos power 4t dt, it will be actually differentiation of f e power x only, because this will be constant. Whatever it is, it will be constant. So here it will become f dash e power x into e power x by chain rule. Now because this capital Ft is integral of this thing, you can think of this f dash will be actually this log t cos power 4t. Okay, so here we can write this as log of, because we are taking f dash for e power x, so in place of t we will be putting e power x here into cos power 4 in place of t e power x here into e power x here. So I think this is what we got by direct Leibniz rule also. So this is how this answer comes. Okay, now coming to the B part of this question, which says for x greater than 0 define fx is equal to 1 to x t log t dt, determine the open interval if any where fx is increasing and open interval if any where fx is decreasing. Now this increasing or decreasing will be determined by the derivative of f. So this will be done by again Leibniz rule, or you may do by the method as I told you. So here it will be 1 into x log x and minus 0, you can put it directly. So this is what f dash x we are getting, and my x is greater than 0. Now we will be using first derivative test. Here you can check for x greater than 0. Let me put 0 here. This derivative will become 0 at 1 because log 1 is 0, and here once again they have not mentioned whether this log x is base e or not. I am assuming base is e, otherwise answer may change. In fact, any base greater than 1 will do. Any base greater than 1 will do. Okay, if it is less than 1, our answer may be different. I will tell you why. Here if base is greater than 1, then here my derivative f dash x will be positive and here it will be negative, and there is a change at 1, so this will be a point of minima. Okay, so we can say this fx is decreasing on the interval 0 to 1, and this will be increasing for the interval 1 to infinity. I think that is what they are asking. Determine open interval or intervals for which fx is decreasing, so 0, 1 is the answer, and for open interval 1, infinity it is increasing. If base will be less than 1, I think these two will become opposite. Okay, now second part, determine all local minima of fx if any and the local maxima of fx if any. So here local maxima point, local minima point is actually x is equal to 1, provided that base is greater than 1. Base is greater than 1. If base is less than 1, then I think it will be point of local maxima, not local minima. So local minima point is x is equal to 1, and local maxima, I don't think there exists any such point. Okay, so this is how this paper can be done. So let me show you how questions were given this paper. First was functional equation question, if you remember that FOF question. I will rate this as difficult. Then complex number, where we draw a circle taking -1, 0 as a center. It is medium or too difficult you can say. Then this quadratic, that 8 power x plus some 27 power x, that question. Again, if you get that idea during the exam, it is easy. Otherwise, it is not that easy, I will say. So you can call this as a medium question. They specifically mention that you should write the logic why you have done that way. By writing x is equal to 1 or minus 1, they will not credit you any marks. So you have to do it properly. So that way it can be considered as a medium level question. Then definite integration, this is medium level question because this is directly based on that Wally's formula. So if you know that proof, I think this can be considered as easy also. Otherwise it is medium. Then that geometry question, it is not that easy, I will say. During exam pressure, you can call this as difficult also. It all depends how good your geometry is. So medium to difficult, I will rate this. Then fifth question, where x, y, z, where we made 3 triangles, it was definitely a difficult question because it is not easy to think that way. Then 6a, I think Newton rule of differentiation, it is definitely easy. 6b, maximum minima, it is definitely easy. I think these are not the question of this B part, they are part of A part only. These are the question of A part of that paper. Okay, so this is how this paper was, distributed. So now coming to teaser question, but before that, everybody, if you are preparing for JEE Advanced, please come to know about Vedantu Eklavya. It is one very important thing for you to prepare for JEE Advanced through online domain, online mode. This is one very important thing. Okay, so please Google it. You will come to know what is Vedantu Eklavya. Here I am sharing with you the notice board of our topper pod, where link is given, QR code is given. By clicking on it, you will go to one PDF where all sort of information regarding new batches or new things coming up are given. So please follow it. You will be informed about everything going on in our topper pod. Those who are going to write JEE Advanced in 2023, this is QR code for your Telegram channel, and this is the link for that channel. Please join it. We are putting all important information related to Eklavya 2023. So you will be informed about when new batches are coming or when test will be there. Whatever information related to this Eklavya 2023, you will find it here. Same for 2024 aspirants. Dear all, this is link of VImpact YouTube channel where we have put the solution of JEE Advanced KVPY, and also we are putting solutions of ISI CMI. So please follow this channel and you will find question wise solutions here, and you will find alternate some unique solutions also. Now coming to this teaser question, I have taken actually the same question which I gave you last week also. Here you are given 1 plus x square into 1 plus x by 2 plus x by 2 square and so on up to infinite. You can write this in shortcut in this way, that pi means continued product from r is equal to 0 to infinite. This bracket 1 plus x upon 2 power r plus x square upon 2 power 2r is equal to 1 plus a1x plus a2x square and so on till infinite. Then you have to find a100 minus 8 times a97 upon a100 minus a99. Okay, so one very good question. I hope you will enjoy solving this question. If you have solved this question, please send your solution to eklavyaSupport@vedantu.com with the subject line teaser solution maths. We will check your solution, and if we find your solution good, we will reach out to you and we will make you part of some of our ongoing program. Okay, so that is all for today. Thank you so much. Bye bye everyone. Take care.